You and I, we feel time moving in just one direction, right? It's this constant current carrying us from a past we remember to a future we don't. And yet, when you look at the fundamental laws of physics, most of them don't really care. They work just as well forwards as they do backwards. So that leaves us with this quiet but really profound puzzle. What is it that forces time to only move forward?
Okay, so here's how we're going to break this down. We'll start with the standard explanation for time's arrow and dig into a big logical problem with it. Then, we'll look at a new hypothesis that brings in extra dimensions. And most importantly, we'll be really careful to separate what this new model actually shows from what it only suggests about why time flows the way it does.
All right, first things first. Before we can appreciate the new idea, we have to understand the old one and pinpoint the exact information gap that this new research paper is trying to fill.
I mean, think about it. Every single day, we see things that can't be undone. An egg breaks, a star forms from a cloud of gas, but the physics that governs those atoms doesn't have a built-in forward button. So what's the engine driving this one-way street we call the arrow of time?
For decades, the go-to answer has been all about something called entropy. You can think of it as a measure of disorder. The idea was that the universe moves from orderly states, like a neat compact gas cloud, to more disordered states, like a spread-out star system. So time's arrow was just pointing in the direction of more and more messiness.
But this is where things get, well, a little tricky. There's a kind of intellectual trap hidden here. If you say entropy increases with time, you've already assumed time is moving forward. You're using a result of time's flow to explain the flow itself. It's a completely circular argument.
And that leads us to the real missing piece. Standard entropy is tied to stuff, matter, radiation. But what about a patch of perfectly empty space? Does time just stop there? Of course not. So this gap, this failure to explain time's arrow without relying on matter, is exactly what this new research tackles. So the big question for us is, what does this study actually demonstrate? And just as importantly, where do its conclusions stop?
So to get around that circular logic, this paper proposes a new foundation entirely. It suggests that the source of time's arrow isn't inside our universe at all, but is built into the very fabric, the geometry of space-time.
So the research objective here was to test a really bold idea. Instead of using existing laws, the paper starts with a brand new rule it calls the postulate of causality. All it says is that reality moves from one state to the next, and the next state, by definition, has to have more entropy. That's it. Notice time isn't even in the definition. Forward just means toward higher entropy.
Okay, that sounds great in theory, but how on earth do you test it? Well, the researchers laid out a very clear four-step plan. First, they decided that these states wouldn't be about matter, but about the geometry of space-time itself. Second, they'd have to calculate the entropy of that geometry. If they could prove that this geometric entropy always goes up, then their postulate of causality would automatically create an arrow of time for free.
Now, to actually run these calculations, they had to choose their tools very carefully. This choice of method is absolutely key, because it sets the rules for how we can and can't interpret their results.
So, this isn't an experiment with beakers and lab coats. It's what we call a theoretical model. They used a modified version of Einstein's theory of gravity. But here's the kicker. They applied it to a universe with more than our familiar 4 dimensions. They chose this approach because it allows the geometry of those extra dimensions to change and expand all on its own.
And what this particular setup is really good at showing is a whole new way for entropy to grow. As this bigger, higher dimensional space, what they call the bulk, expands, it's constantly spawning new separate regions of space. Each new region adds a little bit to the total geometric entropy. The final result is an entropy that just keeps growing and growing exponentially, driven only by the expansion of these hidden dimensions. And this is really the core finding of the whole paper. When you run the numbers for a 6-dimensional model over the lifetime of our universe, the growth factor for this geometric entropy is this. A number so staggeringly large, it's honestly hard to even wrap your head around.
So what does that huge number actually mean? Well, to put it in context, the paper finds that this geometric entropy is being produced so fast and in such vast quantities that it completely overwhelms all other forms of entropy we know about, from matter, from radiation, even from all the black holes in the universe combined. What the model shows is a clear, dominant source of entropy growth.
Okay, so the model gives us this powerful engine for creating time's arrow. But that immediately brings up a pretty obvious problem, doesn't it?
Right. This is the essential question. If there's this vast, expanding, multidimensional space all around us, why is our world so stable? Why do we only experience 4 dimensions? The model has to have a good answer for this to be plausible.
And it does. The paper uses an idea from string theory called the Brane-world scenario. Picture this. Our entire universe, everything we can see and touch, is confined to a four-dimensional membrane, or a brane. This brane is just floating inside that larger, higher-dimensional bulk. So the bulk can be expanding like crazy, generating all that entropy, while our little brane stays perfectly stable.
And you know, this might sound like pure science fiction, but we see something kind of similar in our own universe. A galaxy, for instance, is held together by its own gravity. It isn't expanding, even though the space between galaxies is expanding all the time. The brane is like the galaxy. It's a stable island in a much bigger expanding sea.
All right, so we've seen the model and its results. But now comes the most important part of any good scientific analysis, being really, really precise about what this study does not show.
And we have to be crystal clear here. This study does not prove that extra dimensions exist. It just assumes they do for its model. It's built on that postulate of causality, which is a new rule, not something that's been proven. And of course, this is all a theoretical model with some mathematical simplifications. It's not a direct observation of reality. These aren't failures of the study, they are the boundaries the researchers responsibly set for themselves.
So with all those caveats, you might be asking, why does this still matter? Well, because it offers a potential way out of a huge, long-standing puzzle in cosmology, known as the past hypothesis. That's the problem of why our universe started in such a bizarrely orderly, low-entropy state. In this new model, you don't need that special starting point. The arrow of time is just a constant feature of the geometry, always being generated.
So let's circle back to our original question. What can we responsibly say now based only on this paper? We can say that there is now a self-consistent, mathematically workable model where the arrow of time isn't tied to the stuff in our universe, but is instead driven by the constant, relentless expansion of unseen extra dimensions.
And that leaves us with a final and pretty fascinating thought. This model suggests that the forward march of time, something so fundamental to our existence, might just be a local side effect, an echo from a much larger, more dynamic reality we can't see. And that forces us to ask, what other fundamental rules of our universe are being written from somewhere beyond what we can perceive?